All right, welcome back, guys. To continue from what we just discussed in the previous video, I think I wrote a bunch of formulas and just discussed the geometric interpretation, what the derivative represent, how do we get that, how do we go from secant line to tangent line, and secant slope of secant line to slope of tangent line, and from slope of tangent line to the derivative. So it's a lot to really process. So hopefully in this video, when I show an example and try to tie together all those concepts, it help make sense. But otherwise, don't hesitate to ask question during the Zoom meeting. So let's look at an example. Okay, so let this f of x function to be an x squared or a parabola function. Okay, so 4x minus x squared, and let's see, part A. Let's go ahead and find the derivative. So find f prime of x. Okay, so from the previous video, the definition is this here. That's the definition. Okay, so we're gonna follow that. Okay, so f prime of x, we're gonna say, okay, so f prime of x is just the limit as h go to 0 of f of x plus h minus f of x over h. Okay, we're gonna go ahead and plug in x plus h for x, and then x, well, f of x is gonna be just the function itself. So we're gonna go limit as h go to 0, f of x plus h. So on the side here, guys, I'm gonna go ahead and write f of x plus h as following. It's just gonna be 4 times x plus h minus x plus h squared. Okay, so we just plug in the input as x plus h into the function, so we get that result. Then we have to simplify that as well. Okay, so x plus h is that, x plus h squared. So this entire thing is the first part. Okay, now minus f of x, where f of x is this thing here, the given function. So it's just going to be 4x minus x squared parentheses. Okay, you gotta use a set of parentheses, otherwise the math won't check out. Okay, all right, so equals limit as h go to 0. So we're gonna simplify this. So I'm gonna do this a little bit fast, and you're gonna have to check my work on the side somewhere there. I'm gonna go ahead and distribute the 4 into x plus h, so that becomes 4x plus 4h. Okay, minus, I'm gonna keep this parenthesis here just now. I'm gonna go ahead and square the x plus h on the side. So x plus h squared is going to be x plus h times x plus h. So you have to use a FOIL method to get this out to be x squared plus 2xh plus h squared, close parenthesis, close bracket. Okay. Then I'm going to go ahead and distribute this negative sign to both of these terms. So that's become minus 4x plus x squared over h. Oh, I missed the h over there. Okay, equals limit as h go to 0. Okay, so I'm gonna go ahead and skip a few steps here. Okay, so notice that there's a 4x there, and then there's a minus 4x, so that's gonna cancel. Okay, and when we distribute this negative sign there to these terms, okay, I'm gonna get minus x, and then there's a positive, minus x squared and positive x squared, so that cancel as well. So what I have left on the numerator is just going to be 4h minus 2xh minus h squared divided by h. Okay, so to evaluate this quotient at this point by plugging h equals 0 to this quotient, we're going to get 0 over 0, and that's indeterminate form. So this quotient defined when h is not 0. Okay, so how do we do this? What we want to do is we want to be able to factor out h and cancel that, because this the way it is right now is it's not defined when h is equal to 0. So we're gonna make sure h is not equal to 0. So I'm gonna go ahead and factor out h in the numerator. So 4 h comes out, and then let's use a different color. H, so that we got 4 minus 2x minus h divided by, in the denominator, we're going to get h right there as the original one, and we can cancel out the h from there. Okay, so now we're left with limit as h goes to 0, 4 minus 2x minus h. Okay. So now we can evaluate this limit. So this is saying that what happened to this expression, what happened to this output, this entire output here, as h value get really close to 0. H gets close to 0. Okay. So when h get close to 0, you have 4 minus 2 times x minus something that very, very, very small, like so close to 0. Well, if we do that infinitely many times until h get so arbitrarily close to 0, then the answer here is just going to be whatever the result of 4 minus 2x is. Okay. All right. To make this easy, you can just think of this as just plug that 0 there. Because this function here, this 4 minus 2x minus h, this is a continuous function and is defined at h equals 0. So we can go ahead and plug h in there. Okay, but that is the derivative. So we say f prime of x is equal to 4 minus 2x. Okay. All right. So all that math to get f prime of x. Okay. So now let's look at part B. How do we use this? Okay. So part B. Let's see if we can use this f prime of x to make sense of it. Okay. All right. So let's go ahead and find f prime of 0. No, I don't want to do f prime 0. I want to do f prime of 2, and then another one, f prime of 3. Let's go ahead and do that. So this is just saying, okay, well, take the derivative function and plug in the 2 for x. So that's just 4 minus 2 times 2. So that's just going to be 0. And then take the derivative function, plug in 3 for x. So that's just 4 minus 2 times 3. So that will give us negative 2. Okay. All right. So this part is not too bad as long as you get the derivative function correct. Okay. Finally, part C. Okay. Let's make sense of what we did in B. Okay. So we say graph f of x and interpret f prime of 2 and f prime of 3 geometrically. Okay, so let's go ahead and do that. Okay, so I'm going to go ahead and graph this function for you. I know it's been a while for many of us to graph a parabola. Okay. Oh, that's kind of slanted, so I want to do 2. Okay. All right. Okay. So to graph f of x, so what is f of x here? F of x is 4x minus x squared. Okay. So to graph this here, we use x and y intercept first. So the x-intercept is going to be 0, and then 4. 1, 2, 3, 4. Okay. And that's just setting y equals 0, so we get this here. We get x and then 4 minus x. So that those are the x-intercept. Okay. The y-intercept, by plugging 0 for x, we get the y-intercept is going to be at 0 as well. Okay. And another thing come up when we graph parabola is the vertex. And the vertex, the x-coordinate is going to be half distance of the 2 x-intercepts, so the average of the 2 x-intercepts. So the vertex is going to be here for the x, it was 2. And then if we plug in f of 2, that will give us the coordinate, the other coordinate for the vertex. So that's 8 minus 4 is just 4. So 1, 2, 3, 4. Okay, so up here. Okay, so there it is. We got what we need for to graph the parabola. So it's gonna be an upside down parabola. Okay, that doesn't look so good, so I'm gonna go ahead and try that again. Okay, there it is. So that is the graph of 4x minus x squared. All right. So if I draw a tangent line that touches the graph at x equal to 2 there, this tangent line here, guys, this tangent line has a slope equals 0, right? Would you agree with that? That's a horizontal slope, so that's going to be 0. Well, that's what f prime of 2 is. So right there, the slope is equal to f prime of 2. Okay, let me try that again. So f prime of 2, what we just found up there, is 0, and that is the slope of the tangent line to the graph at x equal 2. What about when x is 3? Well, 3 is right here. Okay. All right. And what we found there is the slope of this tangent line. That slope of tangent line, the slope, is -2, and that is f prime of 3. Okay. So the derivative function allows us to find the steepness on the curve at any position throughout the entire curve. Okay, and that's what we did here, all this math. Okay, the next couple lessons we're gonna learn the shortcut to do this much quicker than the long way, but I feel like this is really good for algebra practice and mathematical writing and all that stuff. So I encourage you guys to do several of this on your own. Okay, it can get a little bit messy, but lucky for us, we're not gonna look at complicated function in this class. Mainly just gonna be linear and polynomials.